I have an upcoming project that requires some custom springs, and up to this point I've had no way of manufacturing my own springs at home. So today in the workshop I shall be making this custom spring winder from Hemingway kits. It uses music wire up to a diameter of about 2.5mm, which I believe is about 13 gauge. And by varying the diameter of the spring, the length, the distance between the coils and the diameter of the music wire, we can come up with custom springs to cover an enormous range of use cases. So in this video I'll take you through the process of making this tool, and then later in the video I'll show you how to use the tool to make custom springs in the home workshop. I bought this kit from Hemingway Kits in the UK, and it comes with all the bar stock that you need. It comes with the plans, some excellent build notes, and it even comes with like a long series drill that we're going to need for one of the operations. The first thing I'm going to tackle is the handle of the tool, and this is made using the supplied aluminium bar stock, which is 1 inch in diameter by about 6 inches long, and the first job is to face it off. Now we need a means to get the piano wire that we're going to be using to form the spring from the back of the tool to the front of the tool, where it's going to be wrapped around the mandrel that we're going to be using. And the way that we're going to do this is to create a shaft in the handle. This shaft's offset from the centre, so what I've done here is I've scribed a line across the back, I've put a centre pot mark in, and I've offset the workpiece in the 4-jaw chuck. Now, quite obviously, this is a very, very deep hole. It goes the entire length of the workpiece pretty much. So what we don't want to happen is for the drill to flex and to go off course. So what I've done is I've centre drilled it, and now I'm using a long series drill, especially for aluminium. Now you do get a drill with the kit. I just happen to have this one, which is better suited for aluminium. And what I'm doing is backing the drill out very frequently to avoid the chips packing up. And I'm also using lubricant, in this case isopropyl alcohol, which is very good for aluminium. Now I'll swap back to the 3-jaw chuck here, just to turn the OD of the head of the tool. Now the plans don't call for this step at all, in fact, but I just thought it'd look nice to have a nicely turned sort of OD on the tool, and also to have some kind of delineation between the head of the tool and the handle of the tool. One thing that the plans do call for is a rounded nose to the tool. Now you could use a ball turner to do this, but I don't have one, so I'm just using a file. I'm going to turn the other end now, so I'm just going to flip it round and protect the already turned surface with a little piece of aluminium drinks can there. And I'll be supporting the other end with the live centre. Once again, the plans don't call for this step, so you can skip this if you want. It's completely optional. I just figured if I've got the opportunity to make the tool a little bit prettier, then why not take it? And before moving on, I'll just break that edge. The build notes say to put a knurl along the length of the handle, but with the import tool that I've got precisely zero chance of getting a decent quality knurl along the whole length of that. So what I've decided to do is to come in with a form tool and just create these sort of decorative bandings. Now these aren't going to be as grippy as a knurl, but they're going to be better than just the plain shaft, and they look a lot better, I think, than the results that I would get with my import knurling tool. So this is where we are so far. I'm quite happy with the surface finish. The insert that I'm using is sweet. I like it a lot. I think I'm quite pleased with the banding. That's come out better than I think the knurl will have come out, and I'm quite pleased with the delineated sort of head section there as well. The next thing I need to do is to mill a flat on each side of the head to accommodate the dividing disc, the guide stud, the dome nut and the clamp washer. I'm just using the edge finder here to find the centre of the work, and I'm going to be coming in with a 2 flutes steep helix carbide end mill that's specifically designed for cutting aluminium, so we should get a reasonable result with this. I'm just holding the workpiece here in an ER40 collet. Now I've got quite a lot of stick out, so I am getting a little bit of chatter on the workpiece there with this end mill, but I'm still getting a reasonable finish, so I'm not too worried. I could ideally have done with a little bit less stick out with the workpiece, but I couldn't think how else to support it properly in this situation, whilst maintaining enough clearance for the spindle. Now moving on to the other side of the head, we need to cut a little deeper on this side because we need to have space for the clamp washer and clamp nut and the dividing disc as well. So we're going to remove the channel that we drilled earlier, or that was certainly the front portion of it, so that the wire can pass through the back of it and in between the dividing disc and the clamp washer. Just ensuring that we've got enough space on this side of the tool head to do so. We need to offset it slightly. So despite a little bit of chatter, I think that's come out reasonably okay. Now, because I've done this in a collet block, the nice thing is I can just index it around by 90 degrees now, because the next thing we need to do is to put a cross hole in for the stud that's going to hold all of the hardware onto the end of the tool. And of course, the first job is to use the edge finder to find the centre of the workpiece and also the distance from the end of the workpiece, so I know where to place the cross hole. As I mentioned earlier, I've got quite a lot of stick out with this ER40 collet, so I'm supporting the work with a screw jack there, and I'm only using sort of light drilling pressure and plenty of lubrication with the isopropyl alcohol. And I'm coming in with successively larger drill bits here to reach the target size of 8mm. Now, the plans do call for this to be reamed through at 8mm, but I don't have a 8mm reamer, so I'm just going to drill it and hope for the best. I think it's going to be fine. The final operation that we need to do on this part is to drill and tap an M5 hole for a grub screw. Now this grub screw will enter into the main bore of the hole that we made earlier and engage with a flat on the stud that we're going to make later. The plans actually call for this hole to be in the centre of the workpiece rather than the centre of our feature. So what I've done is I've moved the hole over to be centralised on the bore. I think it looks a little bit better. And that is our handle finished. The next part we're going to make is quite an interesting one. It's the dividing disc, and this is what sets the distance between the coils of the spring. It's got this rather unusual angled surface to it, so it's 1mm on one side and 5 on the other, and I'll show you how we go about machining that after we've turned the basic blank. The kit comes with some mild steel rough sawn bar stock for this. It's 1 3/4 or about 45mm, and it's just a little bit thicker than we actually need. So you have to be a bit careful about how you hold it in the chuck jaws. And the first job is to face it off, get rid of those saw cuts, and bring it to thickness. And after that, we need to drill an 8mm hole. This should be reamed according to the instructions, but again, I don't have an 8mm reamer, so I'm just going to drill it and hope for the best. I think it's going to be fine. I need to machine a little recess in the front side here to accommodate the guide stud. It's about 1/2 inch by 3/32 or 12mm by just over 2mm approximately. And we then need to flip it round and face off the other side. This insert that I'm using here is specifically designed for aluminium and brass. It's very sharp, it's got quite a high rake angle on it, and yeah, not designed for steel, but I find it works quite well in mild steel. So when I want to get a nice surface finish on a part, that's what I use. Now that we've got our blank sorted for the dividing disc, we can go ahead and put that angled surface on it. And the way we're going to do that is with this arbor. It's got a 5-degree angle machined into one end of it, and 2 M6 threads to allow us to hold the workpiece for turning in the lathe. We'll also drill each end for a pin that will help stop the workpiece rotating as we turn it. The kit does come with this 1-inch mild steel bar stock to make this arbor, and the first job is just to face it off before drilling and tapping for M6. This is just to hold the M6 bolt that is supplied with the kit, which allows us to clamp the dividing disc to the arbor for machining. If you don't have an M6 tap, if you're working in Imperial, I'd probably substitute this for a 1/4 28, but you will have to then supply your own screw. We get the M6 screw with the kit for this arbor. Before moving on with the arbor, I need to put a locating hole in the dividing disc, and this is offset from the main hole by 3/4 inch, and it should be 1/8 inch in diameter. Now, I don't have any 1/8 inch drills, so I'm using 3.1mm, which seems close enough. And I'm going to be using this piece of silver steel or a drill rod that came in the kit to make the pin, so I'm just doing a test fit there, and that seems fine. What I'll do next is I'll mount this part to the arbor that we machined previously, and I'll use this drill rod to locate the part in the mill, and then we can drill through the part into the arbor to drill the recess for the pin. Making the pin's a simple job. It's just a question of cutting the 1/8" silver steel or drill rod to length with a cut-off wheel, and then I'm going to clean it up on the D-bit grinder for no other reason than I just wanted an excuse to use it. I've only just acquired this D-bit grinder, and it's kind of fun. So yeah, more of that to come in future videos. Now I'm going to mount the dividing disc back on the arbor that we've just made and get it back in the lathe just to clean up the OD before we move on to the other end of the arbor. I've flipped the arbor in the chuck, and I'm just facing and spot drilling the other end of it. The reason for this will become apparent in a sec. And I'm going to be using one of these little 5-degree angle blocks to cant the arbor over in the vise so that we can get the correct angle for milling the top of it. It's not all that easy to locate the part when it's canted at an angle like this. Using the edge finder, for instance, on that one plane would be quite difficult. So I've just located the drill and the part in the mill using that centre mark, and I'm now drilling and tapping for M6. And it's important that we do this before we mill the top of it flat, otherwise we'd lose that centre mark, obviously. The length of the arbor is not critical. We just need to make sure that we clean up the entirety of that face and make sure it's dead flat. We need to drill the arbor and fit the pin as we did before, and then we're ready to take the whole assembly back over to the lathe and start machining. Because we've got that 5-degree taper on the top of the arbor, the part itself wobbles and obviously presents one edge to the cutting tool sooner than the other one, which results in the tapered profile that you see across the part. That's the dividing disc done for now. We'll talk more about this part when we come to final assembly and use of the tool. But for now, we've still got some nuts and washers to make, as well as the stud that all of these components ride on. So let's crack on with that. We're using 1/2" bar stock here, which is 12.7mm, just mild steel. I'm turning down this one end here to 8mm so that we can thread it in a moment. We're only going to be threading half of this. The other half is going to be having a flat milled on it for the grub screw in the handle to engage with. Using my shop-made tailstock die holder here. If you haven't seen that before, then there's the full build video on the channel if you're interested. Just doing a test fit there with the handle, but it's a bit tight, so I'm going to go in and take a bit more material off. And that does seem to be a much better fit now. The wire that we're going to be using to make the spring actually needs to pass through this component on its way through the handle and out the front of the tool. So what we need to do is to drill a hole in the central boss here for that wire to pass through. The maximum wire diameter that we can put through this tool is 2.5mm. So I'm going to make this hole 3.5mm just to make sure we've got a bit of clearance. There's a grub screw in the main grip that allows us to lock this component in place. But in order for that grub screw to engage with this, we need to mill a flat on it, and yeah, it needs to run parallel with that hole. So yeah, I'm using the collet block here, and I've just indexed it around by 90 degrees, and we'll just mill a flat on the top there. Back over at the lathe, we have the part mounted in a 5C collet in the chuck here, and yeah, we just need to turn this down to 8mm and thread it M8. A little bit of deburring, and that part will be complete. Just 3 more very simple components that we need to make now. The first of which is like a little clamping nut. This gives us tension on the clamping washer, which allows us to set the tension for the wire going through the tool. So yeah, very simple turning job, nailed it and drilled and tapped it M8. The stock that you get for this in the kit is actually mild steel, but I thought it looked better in brass, so I did it in brass. I need to make a domed nut for the opposite side to the clamp nut that we've just made, and again I'm doing this in brass rather than in mild steel, so just a question of turning it down and then rounding the end off with a file before flipping the part around and drilling and tapping it for M8. And we're on to making the final component, which is the clamp washer. Now this sits between the clamp nut and the dividing disc and provides some clamping force and therefore kind of friction for the wire that's going through the tool. I'm making this out of the supplied UHMWP plastic, some sort of polypropylene. I've not used this before. It machine's very similar to Delrin. We need to simply machine this down into a disc with a hole in the middle. It needs to be 1.5 inches in diameter by 7/32 thick, which is about 38mm by 6mm. And the hole needs to be 17/32 or about 13, just over 13mm. And that's the clamp washer finished. The final thing I want to do before assembly is just to blue up these steel parts. So I'm just going to drop these into a cold blue solution, and hopefully these should have a bit of a better chance of staying rust free going forward. So I'm just rinsing the parts off there, spraying them down with WD-40, and then once the blue is hardened I'll come back and coat them in probably whey oil. So that's our parts all finished and time for final assembly. So I'm just going to take the guide stud there, slot that through into the dividing disc and fit that to the handle. Now there's a flat milled on that guide stud that we did earlier on, and that's going to interface with the grub screw that I'm tightening up in the handle there. Just want to make sure that's tight and engaged so that we don't get any movement whilst the tool's in use. Off camera, I did go ahead and make a brass washer as well. Now, I mean, you get a steel one with the kit. I just figured as I did the nut in brass, I'd do the washer in brass too. And on goes our nylon clamp washer and the brass clamp nut. So that's our tool complete. The only thing that I haven't done is to inscribe these index lines and numbers on the side of the dividing disc. These signify the thickness of the disc and therefore the distance between the coils of the spring. And they should be inscribed on this side of the dividing disc here. The reason I haven't done this is because I simply don't have the means to index this and inscribe it and engrave it correctly. So for the time being, I'm just going to use a set of calipers to measure the disc where it contacts the mandrel that we're going to be using to turn the spring. So let's get to making some springs, and the first job is to insert the piano wire through the hole in the bottom of the handle and up through the shaft in the handle to the hole at the top, and then it needs to go through the hole that we drilled through the middle of the guide stud. Now we just need to install our nylon washer and nut, and the function of these two components is to create some friction on that wire so that it's pulled tight when the spring is being formed against the arbor. I'm using a piece of steel here as an arbor, and I've just cross drilled it, and I'm just going to put the end of the wire in there to trap it. The other thing you can do is to drill and tap this and to trap the wire with a screw. And the next thing I'm going to do is just set the tension on that wire just to make sure we've got enough friction, and then we're good to go. One thing to note is that obviously we're going to have some spring back once we release the tension. Now, the amount of spring back depends on the gauge of the wire and the mandrel size and a number of other things. I think spring design is probably beyond the scope of this video, but I will make a video in the future on specifically on that if people are interested. If you are interested, please let me know in the comments. One thing to note is when you're starting out, make sure that your dividing disc is clear of the wire, or that kind of thing can happen. So yeah, just be wary of that. Another thing to watch out for is that some wire gauges and arbor diameters work better than others. I was trying a really big arbor on this one and ended up with something akin to a super slinky. So yeah, some experimentation might be required there. Otherwise, all of these facts and figures are available in the machinist's handbook as far as I'm aware. So all in all, I've been really impressed with the quality of the springs that I've been getting from this tool. They seem to be more than adequate for what I need, and I'm looking forward to experimenting with this more in the future. Like I said earlier, if you guys are interested, let me know in the comments and I'll make a more detailed video on spring design and manufacture. If you like this kind of content, I've got plenty more tool making projects coming up on the channel, as well as a host of other things. So do stay tuned for that if you're interested. And if you do want to support the channel, then please do drop me a like and a subscribe. It's very much appreciated and it really does help the channel. Thanks for watching, folks. I hope to see you next time.